this tutorial I'm going to be doing forecasting. So I'm going to be doing simple moving average, weighted moving average, exponential smoothing or smoothing constant, and linear trend. So let's first start off with simple moving average. So I'm just going to do SMA, and it tells us that we're going to be doing 3 years. So develop a 3-year moving average. So our first 3 years aren't going to have any data in this, and that's because it wants the average of the 3 previous years. So if we don't have data for before year 1 because we started on year 1. So if we just go to 4 and do average of the 3 previous years, and then copy this down all the way down to 15, we get what the simple moving average would predict for the demand. So next what we're going to do is the MAD, or the mean average distribution. So it's just the absolute value between the difference of what we predicted and what the actual demand was. So if we just do ABS, which is the absolute value, and it doesn't matter which way you do this, it's the actual minus what we predicted in SMA, or SMA minus the actual demand, and close it off. So if we just drag that down all the way to 14, not 15, because we don't have data right here, and we do an average, of this, and we see that the average mean distribution for the simple moving average is 3.42. So there's an average of 3.42 difference between what we predicted and what the actual was. So now let's do the weighted moving average, or WMA 3-year. And we know it's a 3-year because it says that the most recent year is given a weight of 2 and the other 2 years are given a weight of 1. So that's how we know it's a 3-year. So if we just do year minus 1, year minus 2, and year minus 3, we see that, and give the weights here, so 2, 1, 1. So the most recent year is going to be given a weight of 2, and the other 2 years are a weight of 1. Excuse me. So what we're going to do is the same as we did with the simple moving average, but we're going to use weights. So just equals sum product, and then we'll do these 3 years. So we're always going to use what the actual demand was right here, and our weights, and we're going to hit F4 so that we lock the weights, and divide that by 4. And I'm using 4 because it's the sum of the weights. I could also do sum of this as well, and we'll get the same answer. And I'll need to lock those cells. And if you forget, you have to do both of them. And then we can just drag this down to 1 passed. And then let's also do the MAD for this. And it's going to be the same thing as last time. So, and it's always going to be at the actual demand. So just drag this down to 1 less, do the average, and we see that it's 3. So this one is the weighted moving average is actually a better predictor of what the demand will be than the simple moving average, because the mean average distribution is lower, so there's a lower difference between the actual and predicted. So let's move on to the smoothing constant. So the smoothing constant, I'll do SC. It tells us what we're going to start off with, so 4, and we're going to start on year 1 for this, and what the SC is. So SC equals 0.4. So the formula for this is equal what we predicted plus the smoothing constant, lock that cell, and that's going to be times the actual minus predicted. And then we can just drag this down. And we'll get the MAD for this as well. So just equals ABS again, this minus this. So the predicted minus the actual. So we can just drag this down one less, equals average. And we see that it's 3.6. So this one's actually the worst one that we can do so far. Then it goes simple moving average and then weighted moving average. So the next one that I'm going to show you is linear trend, so LT. So with that we need slope and intercept. So to find slope, it's really easy. We just do equals slope and then y's, then x's. So y is what we're trying to predict, and x is our x's. For intercept, it's just equals intercept. And this one's also y's and x's, so just highlight y's and then x's. So to find linear trend, it's just equals the intercept, lock it, plus the slope, lock it, times what x is. And we're not going to lock x. And then just equals, or enter. And then we can drag that down. And then we'll do MAD for that as well. So equals ABS, this minus this, and then drag this all the way down. And we can just do equals average again. So we see that the linear trend is actually the better forecasting model. And that is it. Hope you found this helpful.